Humans, welcome to the video presentation of solving absolute value inequalities. Know that this is trademarked, so there is no reproduction or sale or distribution of said video. Here we go. We're going to talk about the very basics of solving inequalities that have absolute value brackets in them. It boils down to two scenarios. At the end of your solving an inequality that has absolute value in it, you're going to try to isolate these absolute value brackets. When you do that, it's the first step, isolate those absolute value brackets. Then you're still going to have the absolute value brackets and the inequality sign. You're either going to have one facing this way with some other hoobly blah on this side, or you're going to have the inequality sign facing this way with some hoobly blobbly on this side. So at this point, you're going to need to be aware of the two methods we use to solving inequalities that look like this and inequalities that look like this. Let's make this a little more clear. I've used an actual number so it makes a little more sense here. In the first scenario, we're looking at the absolute value of x that's less than 12. Well, let's think about what would make this equal to 12. If you had a negative 12 in there, you would get 12. If you had a positive 12 in there, you'd get 12 as well. So you're looking for something that ends up being less than 12. So I think it's got to be a number that's in between negative 12, like negative 11, negative 10, all the way back up to 11, and then 12. Because when you're looking at x, it has to be in between these two ideas. If it were outside of these ideas, the absolute value of negative 13, say, on the low end is 13, which is not less than 12. That doesn't work. If you went on the high end of 14, absolute value, that's not less than 12 either. So what you'd be looking at is a compound inequality that maintains this idea. Whatever's in the absolute value brackets comes here, and what you have is what's known as an AND inequality, where x has got to be less than 12, but at the same time, it must also satisfy being more than negative 12. That's one case. And I like to say less than and, less than and. For the second case, if you look at this idea, it says the absolute value of x is greater than 12. Okay, so whatever ends up over here at the left must be greater than 12. That's going to be the case where you have this idea, stuff that's bigger than 12 will be bigger than 12 if you take its absolute value, or another inequality that satisfies this will be where x is less than the opposite of 12. Let's take a look. Let's inspect. Think about it. If you're looking outside of 12 on the big end, you'd look at like 13. The absolute value of 13, is that bigger than 12? Yes, that works. Looking here, again, you need a number outside of 12 because when you take an absolute value of something bigger than 12, whether it's a negative number, like outside of negative 12, but smaller, I guess, a bigger negative number, negative 13 actually works in this case, negative 13, because you're taking the absolute value of it and seeing if that's bigger than negative 12. So 13 bigger than negative 12? Of course. So, again, this is what we refer to as an OR inequality. If ever you have this idea where it's great or, get it? So the absolute value is greater, or you split this inequality, you write one exactly as it appears, like so, and you write the other as the opposite and reverse that inequality sign. Ooh, notice that. Let's go and get some practice with this. Here's an example, and I hope you can notice right away that you have the less than sign facing the inequality. So this will be an AND inequality, a compound inequality of the form this. You have some numbers out on the edges here and an x in the middle. So your numbers will be in between two values that satisfy this inequality. Let's go ahead and solve it. Divide 3 on each side. And remember, the first goal is to isolate these absolute value brackets. When we do that, we'll have a 4. And so we've got the absolute value of x plus 4 is less than 4. Since it's an and inequality, we can rewrite with the stuff that's in the absolute value brackets showing up in between these two quantities of 4 and negative 4, maintaining the integrity of this inequality sign as it shows here and here. Now we solve it like a regular equation, negative 4 all over the place here. So on the left end we've got negative 8, x is by itself, and we've got a 0. So the solutions, plural, for this inequality are the numbers in between negative 8 and 0. That's what would make this statement above true. Easy enough. You try one. Pause the video to give this one a try. And remember, your first goal is to isolate these absolute value brackets, decide whether you've got an and or an or inequality, and set it up appropriately to solve. Good luck. Now we're moving on to the next idea. And the next idea talks about those or inequalities. So let's have a very similar problem here. And we're going to reverse that inequality sign this way this time. And this is what we're working with. First goal, again, to isolate these absolute value brackets. In this case, we'll divide 3 on both sides, leaving a 4, x plus 5. Now we have the case where what's in here needs to be greater than 4. Great or, so this is an or inequality. That means we can set it up with an inequality just as you see here, or it could take the form as the negative version. Be careful to reverse this inequality sign and make this number negative. So here's the only change outlined in red. This reverses and this becomes negative. If you solve each of these, you'll have some solutions that work. X, as we see it over here, is going to be more than negative 1. And over here you can see that x will be less than negative 9. So if you were to take a number that's less than negative 9 and plug it in the original inequality, you would get a true statement. Also, if you were to take a number that's bigger than negative 1, like 0, 1, 2, plug it into the original inequality, you would get a true statement. So either the set of numbers that's bigger than negative 1, here, or the set of numbers that's less than negative 9 will work for this inequality. And I trust that you can graph this as well. You try one. Here you go. Go ahead and try this one. Remember, your first job is to isolate these absolute value brackets by using inverse operations. Decide whether you have an and or inequality. Set it up accordingly, and then solve to figure out the set of numbers that makes this inequality statement true. Good luck. I'm looking for these two problems to be shown to me in class tomorrow. Illy.